Hello, everybody. I'm Daniel. I work for Acvo, and we are going to talk today about efficient developers. So let's get started by defining what we mean by efficient developers. To be efficient is to achieve maximum throughput with minimum wasted effort. And in our case as developers, that effort is usually time. So to be efficient is to do things really fast. Now, this definition is missing a key element that is really important for our work, but that we can find in this quote by Peter Drucker. To be efficient is to do things right, while to be effective is to do the right things. So to be efficient is not just about hacking your way to go really fast. It's about making sure that whatever decision that you make today is not going to slow you down in the future. So to be efficient is to do things fast, but do them in a proper way. Now that we have this quote here, you maybe wonder, well, what's more important, to be efficient or to be effective? Obviously, it makes no sense at all to go really fast if you never and end up on the wrong place. While equally, it doesn't make any sense to know where you want to go, but never arriving to that place. So both things are important. In fact, there is some synergy between them. The more efficient that you are, the more time that you have in your hands to stop, look around, making sure that you are going on the right direction. So being efficient gives you more time to be effective. Now, in this talk, we're just going to focus on what will make us more efficient. There are several studies that try to quantify what's the impact of interruptions in our work as developers. And it seems that every time that we are interrupted, we waste between 10 and 15 times of time, of 10 and 15 minutes, to load back into our head the context of the task that we were doing before being interrupted. So to be efficient is paramount that we reduce the number of interruptions to a minimum, so that we have long periods of time where we can focus on the task at hand. There are basically two types of interruptions, the ones that you control and the ones that other people control. The ones that we control, this is probably the worst offender. If you think that little pop-up does nothing for your concentration, the truth is that for your brain, it looks more like this. Millions of years of evolution have made our brains very sensitive to any unexpected movement, mostly because of the fear of being eaten. So by the time that the pop-up disappears, you have read the subject, the sender, and your brain is already working on it. So the first habit of efficient developers is disable all notifications. So not just email notifications, but all of them. In fact, you don't even want to see the number of unread notifications anywhere on your screen. The only notification that you want to see, and that one you want it on your face, is the one that tells you that you broke the bill. Now, I think email is amazing because it's asynchronous. You can deal with it in batches. Nobody expects that you will reply to it immediately, and you can choose when to handle it, when to be interrupted. In fact, I think we don't use email often enough. So I want to ask everybody that before going, next time, before going and interrupting one of your teammates, to think twice if you really, really need that answer right now. Because the same way you hate to be interrupted, other people also hate to be interrupted. Now, whatever you do, please never be one of these people that they type and they send you an email and then they run to tell you, or they ping you, or they call you. This is extremely annoying. Now, this takes us to the second type of interruptions, that the other ones that other people control. What can you really do when somebody else comes to your desk to interrupt your work? I can think of three possible options. The first one is to wear some headphones, and the bigger the headphones, the better. So that when somebody comes to your desk, you just pretend that you didn't see them, with the hope that they just get bored and walk away. The second option is to have a very, very good team lead. Somebody like this guy. Somebody that is able to handle any interruption before it reaches the team. And the third option that I can think of is doing pair programming. When you do pair programming and somebody comes to interrupt, what should happen is that one of the developers in the pair should stand up, walk up a couple of meters away from the pairing station and handle the interruption. And when he comes back, the developer that stayed, but managed to keep focus, will work as a really fast cache that will get you productive in no time. Also, if you're doing pair programming, you will have the additional benefit that because there is somebody there just looking over your shoulder, you will check your email less often, you will check your phone less often, you will check the news less often. So that's just peer pressure of having somebody sitting with you. It will force you to be focused for longer. Now, I don't think I need to talk, explain anything about this thing. We all know it, and I don't really want to sound like your mom telling you to eat your greens. So let's move to the next section. Efficient developers just want to do one and only one thing at a time. And the reason is the same why we hate interruptions, because of the context switches. Here we say that doing the blue task after finishing the green task, it takes less time. But doing one thing at a time not only takes you less time. When we try to do multiple things at the same time, the quality of our work usually suffers. Remember that the definition of multitasking is screwing several things at once. So just do one thing, focus on it, and then move to the next one. As developers, we are going to spend hundreds of hours in front of our ID. It's one of our main tools. So any efficiency that you gain while using it is going to be multiplied by those thousands of hours that we are going to be there using it. To master your ID, you basically just need to learn two things: its functionality and the shortcuts to use that functionality. Now, just because you are already using your ID for 6 or 8 hours a day, that doesn't mean that you're going to master it. To master it, you need to make a conscious and deliberate effort to actually learn about it. You can learn about it reading blogs, reading the release notes, looking at YouTube videos, and you can also use pair programming. When you're doing pair programming, you're going to see each and every of your teammates using the ID. You're going to learn about new functionality. You're going to see different ways of achieving a task. Also, it's going to give you the opportunity to show all your teammates all the tips and tricks that you know, making the whole team more efficient. I'm always very surprised and a little bit sad of seeing how much manual work we developers are able to put up with. And I found it quite paradoxical, given that we are basically paid to automate other people's work. Yet we fail to do the same with our own work. Manual work is not just less efficient, it's dull, boring, and error-prone. So I always wonder, well, why we keep it doing it? I think that sometimes it is because we forget that we are developers. And as developers, we have this very rare and powerful skill that allow us to create an army of minions that will do exactly as we tell them, without arguing, without getting tired, and will do it very, very fast. And I think we don't use this skill often enough for our own benefit. Maybe sometimes it's because the minions that we create, they don't really behave as we expect, but that's another matter. Just to make sure that these things, I'm going to say it again, we are developers. We should never do something that our computer can do for us. So the first thing that you should do before starting any task should think, can I write a program to help me to do this or to achieve this? I'm not just talking about automating something that takes you hours to do. I'm also talking about those 5 or 10-second tasks that you do very often. In fact, I'm also talking about that one of tasks that you never, ever do again. First, because probably it's more efficient, but second, because I hope that for you, as it is for me, writing a program is always more fun than doing things by hand. Now, to write simple programs, there's nothing like Bash. On my 20 years as a software developer, I have changed IDs, I have changed programming languages, I have changed operating systems, I have changed my mind about all kinds of practices and tools. The only thing that has been constant during those 20 years has been Bash. Now, you don't need to know a lot of Bash to actually be efficient with it. And I'm going to do a little demo about what you can get with Bash. Here we say, let's assume that there's a product manager that comes to you and tells you that there has been another team that has written some application that is collecting news into some remote server. And he gives you the IP of the remote server, and it tells you which directory all those files are being collected. Now he asks you to tell him how many news we are getting for each of the countries. So you jump to the box, and the first thing that you do is check what's on that directory. And the second thing that you are going to do is actually write a little program for yourself. So we know that there are around 4,000 news. So that's our first program. So let's now have a look at what one of those files contains. So we say that is some kind of JSON. So let's format this so we can see it a little bit better. So if we look around this file, we'll see that it says here that which country it belongs to. So we're going to try to extract that. And instead of using GQ, I'm going to go a little bit more brute force. So let's go brute force. So we want to grep. Let's try to get the country of this country. There it is. So the country is there. Let's color it. So we see here, where are you? We see here that we're getting the country. So now let's try to extract that country. Just -O, just to get the thing that was match. And that gives us the country itself. And now we're going to use cat with a code delimiter. And we think that is field, one of those fields. And we say it's field number 4. So we have now the country for that one particular news. So we do this for all the news. We have all the countries. And if we sort unique minus count, we get there the number. Let's sort it again. Cool. So that's our first application. In very little time and doing little steps and getting feedback, really fast feedback, we're able to know which one are the most, the country with the most news. Now let's say that instead of the country, we actually want to see which sites we're collecting the most news. Yeah. Cool. So now that we have these sites and countries, our product manager comes and says, like, okay, can you give me the top 3 sites per each country? So what we need to do, we already have an application that let's try to. We already have almost there. So what we're going to do is we're going to try with one particular country. Let's try Israel. Let's see if this works. Cool. So these are all the news for Israel. Now, instead of sorting, we reverse it. And now we do head 3. We have there the 3 news. And now let's format it. So we have in one line. So now we have the top 3 news for one particular country. So now we just need to do a for loop. So let's do a for loop. So we have to get all the countries. Where are you countries, sites, countries? So basically you are using the same program that we used before. These are all the countries, and now we just need a for loop. For en, do echo $e. We check that we are actually, our for loop is good. And then we run that. That's all for Israel. So now we just need to replace the Israel $I, and then we need to play the quote unquote game. Quote, 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 unquote, quote, unquote. And there it is. So you can see with Bash and with little commands, you can do a lot of stuff that's going to make you more efficient. Now let's go back. Now, word of caution, before starting to write any program for yourself, the first thing that you should do is decide how much time are you willing to spend to write a program. Because it's too easy for us just to get lost in time when we're writing any application. After that time has been elapsed, you should just give up and go back and do things manually. Now, you should never think that just because you didn't finish or didn't manage to get the whole task done, that's a waste of time. You should think about it as time that you are invested in yourself, on learning. So that next time you will get a little bit further and you just make yourself efficient one bit at a time. Now, if we're talking about writing programs, you should, avoid any kind of graphical user interface. Why? Because you cannot put a UI inside a for loop. They cannot be part of any pipeline because UIs do not compose. UIs live isolated in their own little world. Now, this is not to mean that you should never use a UI, because when you are a beginner, UIs get you productive really, really fast. But once you are past that phase of beginner, UI is just going to constrain what you are able to do. So to be efficient, you will need to let those UIs go. And if we are talking about avoiding UIs, the first UI that you should avoid is your own application UI. There is nothing less efficient to check that you did not break the application, that start clicking things around and filling up forms. That's just a big waste of time. But the most important thing about automated tests is that they catch bugs, and bugs are the second worst time waste of all. First, you need to write the bug. Then you have to get somebody to code review that bug. Then you need to put the bug into production. Then some user will have to report the bug. You have to triage it. You have to create a Jira issue for it. Then you need to dig into your own code that maybe you wrote weeks or months ago. And then you need to do the bug fix. When you have the bug fix, you need to get a code review. You need to explain to your boss. You need to explain to QA. And then you need to go through the whole painful process of putting that bug fix into production. So the whole thing is just a big waste of time. But worse than having one bug in production is to have the same bug twice in production. So please, before fixing any bug, first write a test that proves that you are able to reproduce the bug. Once you see the test failing, it's when you can go and with confidence fix that bug. The last manual chore that you want to avoid is setting up the development environment for your own application. This is not just going to make you more efficient, it's going to make the whole team more efficient. Whenever I join a project, this is the kind of instructions that I see on the wiki. And the only thing clear about them is that they're not going to work. Either they're out of date, which probably they are, but even if they're not going to be precise enough, or I'm going to make a mistake following them, or I will have something installed on my local environment that will make them fail. And the result is always the same: 2, 3, 4 days wasted time. What you should aim for is just one command that should download, install, and configure anything that you need to build, run, and test your application. So if your application needs a database, that one command should download and install the database server with the correct version and seed it with whatever data you need. If you need Maven on NPM, that one command should download the correct version of it and get it ready so that after running this one command, any developer should be able to contribute to the project within minutes. As you can see, my tool of choice for this is Docker. If you're using something like Docker, the first amazing thing about it is that the setup instructions, they never ever get stale. Because to make any change on the development environment, you need to change those Docker files. Also, those Docker files are part of your source code, so they can be reviewed and they can be rolled back. And once they are there in the repository, anybody in the team, after one change, can enjoy the new and improved environment within minutes. Also, using containers, it means that everybody in the team is going to use exactly the same version of Maven with exactly the same version of the JDK with exactly the same version of the operating system, which, cuts a lot of issues out. And the nice thing about Docker Compose is that creates isolated environments. So it's very easy to run multiple different versions of Postgres in your box without having any clashes between them, or multiple versions on NPM. And the last, because it's so easy to dispose of those isolated environments, it means that if you want to try a new version of Postgres or a new version of NPM, you will do it without fear of leaving some trail, some crap behind if the new version doesn't work, because you know that Docker will take care, of rolling back any changes that you have made. Okay, last section of the talk. No matter what task you are working on, you should always try to find the shortest and close and tightest feedback loop possible. Feedback is what tells you if you are going in the right direction. So you want feedback early and often, so you don't wander on the wrong path for too long with the consequent waste of time and energy. We already talked about how important good automated test suite is, but when is the best time to write those tests? I can give you 4 reasons why you should write those tests first. The first reason is the TDD workflow. With this workflow, what you do is first you write one test and only one test, you run it, and you see it fail. Yeah, so you're getting some feedback there. Then you just write enough code to make that test pass. You run your test suite and you see it pass. You are getting feedback there. Then you just refactor a tiny bit of your application to clean up, and you run the test suite and you get some feedback. So after each of these little steps, you are getting feedback. And the nice thing is that if you get any error, any unexpected issue, you know that the issue is in the last tiny step that you made. So it's very easy to find what went wrong. This will make you just go faster. The second reason why you should write your tests first is that tests are an investment. And that means that they are not free, right? You have to build them, you have to maintain them. And when is that investment going to pay? The investment on tests pay when you are modifying the code that those tests cover. So if you build a feature and then at the end you write your test and you never ever touch that feature or that part of the code base ever again, it means that tests are just a big waste of time. If you are writing your test, as you write the code, it means that the tests are covering that code that you are changing. So the tests pay off a lot earlier. So if you write tests, it just makes sense to write them first. The third reason to write tests first is an organizational issue. I don't know how many times I have heard the phrase, well, I don't have time to write tests, or I'm not given the time to write tests. And for me, this always sounds like, well, you are probably writing your test last. And because you are writing your test last, if there is any time pressure, and there is always time pressure, what's going to happen is that you don't have time to do the thing that you did yet, which means that you don't have time to write your tests. Because you write less tests, it means that you probably are doing less refactoring, because to be able to refactor, you need to have a good test suite. Because you don't have time to refactor, it means that your code starts to accumulate more garbage. And the more garbage that your code accumulates, the longer it takes to implement new features. And the longer that it takes to implement new features, the more time pressure that you get. The more time pressure that you get, well, you get less time to write tests, closing a vicious cycle that always ends up with us developers crying for a rewrite. And the fourth and last reason why you should write your test first, it's a mechanical reason. Because seeing a test fail is the test that tests if the test tests what it's supposed to test. Or in other words, how do you know that your test doesn't have any bugs? If you write a test and you see it green, then there is a strong indication that there is a missing piece of production code that test code. Now, if you write a test and it's straight away green, you don't know if because you already wrote that production code or because there is something wrong on the setup or on the assertions that test. Now, when you present this idea about writing tests first, a lot of developers come back with like, well, I cannot write a test first because I don't know what I'm going to build. Now, this can mean several things. It can mean that you don't really understand what business is asking you to build. And in this case, it's true, you cannot write any test. But honestly, you cannot write any production code either. What you have to do in this case is go back to business and ask for clarification. The other case is that you actually understand what business is asking you to do. You understand the business logic, but you're not sure if you're going to write one class, 10 classes, if you're going to use an if statement, if you're going to use an if or an enumeration or an abstract factory. You're not sure about what structure your code is going to have. Also, you understand what are the mechanics of the side effects that you need to produce. By this, I mean that you are going to use some database and you have used that database 1,000 times, so you know it inside out, and you have no question, no doubts about how that database is going to behave. In all these cases, you should be able to write your test first. Now, there are some times that we don't really know the kind of side effects that our application needs to produce, right? The mechanics of those side effects. And by this, I mean, maybe it's the first time you're going to call some HTTP service, and you have never, ever called that particular HTTP service. So you need to go and make some calls, see what kind of result it returns, try to see if you pass some wrong parameters, what kind of error it's going to get. So you're trying to understand what kind of error handle you have to do. Maybe you're using a database that you have used 10,000 times before, but it's the first time that you use that particular schema. So you need to find out which tables are there, what are the relationships. You need to dig to try to understand how the real world works. So in our job as developers, we always go through this exploration phase where we try to fill the gaps on our knowledge to try to convert those unknown side effects into known side effects. And for this, I think TDD doesn't give us a lot of tools. For this, the best tool that I know is a REPL. REPL stands for Read About Print Loop. And it's like having a command line interface inside your running application with your production language. Instead of trying to explain it, let's see a little demo about what is a REPL. So I already started an application with a running REPL, and what I'm doing right now is connecting to that application from my favorite IDE. Now what I'm going to do, let's say that I don't understand how the plus function works on my programming language. So what I do, I write a little program, this is my little piece of code, and I send that command with a shortcut to the REPL, to the running REPL. And the running REPL here tells me this is what you send me, and this is the result of that code. Now let's say what happens if I pass 3 parameters. I again send that application, that piece of code to the REPL, and I get the response. Okay, so what happens when I pass a very long value? I get an exception. Okay, that's interesting. What happens if I just pass 1 parameter? It still works. And if I don't pass any parameters, it still works. So what we are doing here is writing little pieces of code and running them inside the running application to understand how the plus function works. And we could do this not just with simple functions, but with any concurrency function, with any GMS library, with any Kafka library, with anything that you will use in production. So we are learning really fast how things work. Okay, let's get a little bit more fancy. Let's say that your application needs to know the Forex exchange, the exchange rates of the current some currencies. Do some of your logic. So first thing, we're going to call that endpoint. Yeah, that's the endpoint. And we see here that is returning some errors. So what we are going to do is we are going to catch that exception, see what data we have in that exception. Here we see that the server is returning with a 400, which means that there is something wrong in our side. And we see in the body that there is some JSON thing. So let's track the body. There's the body with some kind of JSON. Let's parse the JSON. True. There it is. So it's saying that we are missing some date, some query parameter. So we pass the query parameters and we pass a date. Here we are getting the exchange rate. Let's see what happens with a old one. Okay, we don't get data, and if we pass something in the future, we also get data. It's a little bit worrying. What happens if we pass a string? Okay, we're getting an error. If you see what we are doing is we are writing little, we are incrementally writing our application logic 1 bit at a time and running it constantly to get a fast feedback to make sure that we are not making any mistake. And if we made any mistake, we know that the issue is in the last piece of code that we edit. So this gives us a very, very fast loop to look around the world. Now you may be wondering, well, why not use something like Postman to do the same thing, right? We're using HTTP, so we must use Postman for it. The first reason why you don't want to use Postman, you would prefer to use a REPL, is that we are using our production language, right? Which means that we have for loops and if statements and any library that your production language has. The second reason is that if for some reason we wanted to mix this data with data that comes from the database, that if you are using Postman and you're using something like SQL Developer, it will mean that you will need to somehow mix those results. You could not do it in any of those tools. Here, with a REPL, you have your whole production language, which means that you can call, GDBC and HTTP and mix it however you want. Also, a nice side effect of using a REPL to do this exploration phase is that if I grab this code into a function, this is production code. I wrote it, this is production code. And this, if I commit it, it will go into production as it is. So I'm not using a special tool that then I need to translate what I got or what I understood from that tool into Java or or .NET or whatever it is. It's like, well, this is the production code and we know it works. When we deploy this thing into production, we know it's going to work because we saw it working right now. So out of that exploration phase, we are getting production code that is production ready. Cool. Hope that's enough. Now, one of the things that they did not explain in the demo is that when we connect to that REPL, we are actually connected through a socket. And because it's a socket, it means that we don't need to run it locally. We can run it in our test environment or in our production environment, which means that we can connect to those environments. And one of the things with the REPL is that you can actually not just modify the code without stopping the application. We also can poke around the state of the application. So we can look at what's in the cache, what's on which Spring Beans we have. So we can actually play around with the state of the application as it is running. So this is like having a debugger out there ready for you, but without having breakpoints. Now this thing is so powerful that we have this nice story from NASA where in 1999 they debug and fix spacecraft code that was 100 million kilometers away, thanks to having a REPL. I understand that this is probably the most weird part of this presentation. So you have here, a whole presentation just talking about a REPL and how to use it. Oh, last bit. Code reviews are going to give your teammates the opportunity to give you feedback about if your code fits the design of the application, if you forgot any edge case, or if you have any duplication that you were not aware of. So efficient developers, they want their code to be reviewed. Now, there is something very true behind code reviews. When you're presented with this massive, huge pull request with hundreds of changes, I don't know what your reaction is, but mine is like, oh my God, why did you choose me? Why did you choose somebody else in the team? But when you are presented with this small, tiny pull request, you are actually able to give useful feedback to your user, to the author, because you are able to understand the change. Now, even if you are a very disciplined developer and you go through the pain of reviewing those huge changes, what usually happens is that when you give feedback to the author, he usually comes back with something like, well, I think you are right. Well, he never said that, but let's assume that he says like, okay, I think you are right, but I have already spent days or weeks working on this, and the end of the iteration is tomorrow, so I don't think I'm going to have time to incorporate that feedback. And the code is already working, so let's not touch it, right? Let's do something instead. Why don't we merge the code as it is, and we ask the product manager to create a refactoring story. I'm sure he will be delighted to put it on the top of the queue and do it next iteration. And we know that those refactoring stories, they never, ever happen. Which means that your code ends up with more garbage. And the more garbage that your code has, the longer that it takes you to implement new features, which means that we get more time pressure, and you know how this is going to end up. So efficient developers, they don't want code reviews. They want continuous code reviews. This technique consists on finding one of your teammates to sit just beside you. And as you are working on the new feature, this teammate will give you feedback as you're writing your code. You can also even use it before you write your code by having a small design session. For the reviewer, it's amazing because you just have little tiny changes to review because you see them appear on the screen. Also, it has the additional benefit if for some reason you are not able to finish the task. This person that has sit down there with you all the time, he has no trouble to take up the task because he has been behind each and every decision that you have made. So you are avoiding knowledge silos within the team. And last, you can use this person sitting there as your personal Stack Overflow, because maybe as an issue that you are having, he or she will have already seen it. And sometimes you don't even need to ask those, embarrassing questions because he sees what you are doing. Some people call this technique pair programming. So this is all that I have for today. So very briefly, focus, master your IDE, avoid any manual work, and always find yourself the fastest and tightest feedback pull loop possible. And last words, You should always find time in your work to stop, reflect on how you're working, and never ever stop learning. That's all that I have. Thank you very much for your time,